Hello, today we will discuss transformer basics. What is a transformer and how it works? A transformer is a stationary electric machine which transfers electric energy power from one voltage level to another voltage level. We have some electric machines like generator which transfer mechanical power into electrical power, a motor which transfer electrical power to the mechanical power. These two both are rotatory devices. These two both are rotatory devices, but the transformer is an static device. It transfers electric power to electric power from one voltage level to another voltage level, or one voltage or one current level to another current level. Then what is the construction of a transformer? The construction of transformer has some parts. It has two coils. One of them is called primary coil, where input source is applied. Here is the source. And the another coil is the secondary coil. These are secondary coil. The coils are made of copper. They are laminated copper wire. And they are folded on laminated iron sheets. This is iron core made of laminated sheets. These are in equal size. They are made of soft iron and they are laminated by paint or varnish. Now next point, how transformer work and what is its principle. The transformer is based on the principle of mutual induction, that is Faraday law of electromagnetic induction. The mutual induction is based on the flux linkage of one coil to another coil changes the magnetic flux, produce induced EMF, and we know the induced EMF is equal to minus d phi by dt. That is, it is d dt of magnetic flux. This is magnetic flux. You all know it is. So, by the change of magnetic flux, induced EMF is generated. So the source should have such a current which produce magnetic field which changes with time. That's why the flux will changes. So here the primary coil will produce the flux, and this flux is regularly changing. It is regularly changing with time because the source voltage is regularly changing. This induced EMF comes into the secondary coil. This one is the secondary coil. Because the change in magnetic flux will produce induced EMF, and this induced EMF come across the load, and we will get the output voltage. Right? Then how it works? Here is the source. This is alternating source, and this source is the input, and here is the alternating current. This alternating current goes to the input side coil, that is primary coil. So in this primary coil there are some turns. The number of turns in primary coil is represented by Np, and the induced current will come across the secondary coil where the number of turns are Ns. So because of the current, the magnetic flux introduced, and it comes through the iron core, inside the secondary coil. Because this flux is the function of time, it is regularly changing as the source is alternating source. So flux is if regularly changes, there is an induced EMF on secondary coil will be equal to minus Ns, that is number of turn in secondary coil, d dt of phi. So as the induced EMF is produced between the ends of the secondary coil, and we will get the output which is also alternating. It is also alternating. Hence, the flux links again with the primary coil, Because of the induced effect in secondary coil, there will be also a mutual induction on primary, and the EMF on primary will be equal to minus NP ddt of phi. What we are assuming here, we are assuming the flux linkage is 100%, through the laminated sheets. It means there is no power loss in between them. Now we have two equations. If we divide these two equations, we will have ES is to EP is equal to minus NS ddt of phi over minus NP ddt of phi. So these two will cancel each other. So what we will get? We will get ES by EP is equal to NS by NP. So the ratio of EMF between secondary coil to the primary coil is equal to NS by NP. That is ratio of turns of the secondary coil to the primary coil. As we assume here, the power at input side is equal to power at output side. We are considering the transformer in an ideal situation. There is no power loss. So power is product of voltage into current. So it is EP into IP is equal to ES into IS, or ES by EP is equal to IP by IS. They are reciprocal, proportional, and it is equal to NS by NP. So this equation we will use in transformer, and we will use it in numerical purposes. Now, there are two types of transformer. The first one is step down transformer, and second one is the step up transformer. In case of step down transformer, this one, we are using word step down. It means the number of turns in secondary sides are lesser than the number of turns in primary side. So here NS is lesser than NP. If this NS is lesser than NP, then we will have ES by EP is equal to NS by NP. So ES will be lesser than EP. So the voltage will step down. In this case, the voltage we are taking at input side, that is in primary coil, is 1000 volt, and we are getting voltage at output side, that is 200 volt, because the ratio of turns is 50 by 10. So 1000 by 200 is 50 by 10, that is 5:1. But current are in reciprocal way, as it is equal to IP by IS. So current will be 5 times. In input side it is 2 ampere, then in output side it is 10 ampere. So in case of step down transformer, the voltage is down, but current is up. The second type of transformer is step up transformer. This one. As the name, there are more number of turns in secondary coil and number of turns in primary coil are lesser. So in this case, NS is more than N. So ES will be more than EP. Here, at primary side, the voltage is 100 volt. Because of the turn times are 4, so the voltage becomes 400 volt. It is also 4 times. But current is just reciprocal. It is 1 by 4 times. So 10 ampere current comes at output as 2.5 ampere. So in case of step up transformer, the voltage is up, but current is down. These type of transformer are used various purposes. When we need lesser voltage, like in battery eliminator, we use step down transformer. In charger of mobile, we use step down transformer. Whereas for a transmission line, we use step up transformer, where we need very high voltage for transmission and low level of current. So in transmission line, we use step up transformer. Now next point is the efficiency of transformer. What is efficiency? The efficiency is the ratio of output power to the input power. It is ratio of output power to the input power, and it is represented by eta. And eta is power at output side, that is toward the secondary coil side, to the power at input side. That is the source side. In general, the transformer has lesser efficiency than 100% because there is always loss of power during the transformer processes. And in general, the efficiency is lesser than 90%. We explain the transformer principle and working by taking the efficiency is 100%. That is power output to the power input is 1. This lesser efficiency of transformer is because of power losses. There are various power losses like copper loss, iron loss, flux leakage, hysteresis loss, and harming loss. First, we come into copper loss. As the coil are made of copper wire, and we know the copper wire is a very good conductor, but still it has some resistance. And we know resistance is equal to rho L by A. A is area, that is the cross-sectional area of wire, and we may write it as pi r square. Because of this resistance of coil, there is a loss of energy in form of heat, and H is equal to I square RT. So more the resistance, more the heat generation, that is more the copper loss. How we overcome this loss? We use the thicker wire. If we increase the radius of wire, coil wire, it means if we use the thicker wire, then the resistance will be lesser, so heat loss will be lesser. So we may slightly overcome from copper loss by making or using the thick copper wire. The second type of loss is the iron loss. In transformer, we use soft iron between the two coils, so the flux linkage will be there. And this iron plates produce the eddy currents. We don't know if there is a change in current, then there is a change in magnetic field, then there is a change in magnetic flux on the metal produce eddy current. So because of the eddy current, the copper laminated cores produce heat again, and that is called iron loss because of eddy current. To reduce the eddy losses, we use laminated iron sheets. The next loss is the flux loss. Whenever we use the iron core between the two coils, the flux transmit through the iron core, but there is some magnetic line of forces goes to the air. whereas they should go through the iron core. But some of them leaches to the air, and this is called flux leakage. The magnetic field which is coming out from the iron core is called flux leakage. The next type of loss are hysteresis loss. During the transfer of magnetic flux through the coil, what happens? The iron core is magnetized and demagnetized. And demagnetized. In regular interval, that is, it will have a frequency, just like as a source frequency. And during magnetization and demagnetization, there is a loss of energy. So this type of loss is called hysteresis loss. The next type of loss in transformer is Hamming loss. During the transfer of magnetic flux, the eddy current produces, and eddy current heated the iron sheets, as well as they produce some sound, and that energy is called Hamming loss. So that's all about the basics of transformer. Thank you for watching the video.